Graphing transformations using mapping notation. Example 1. Given graph of a function or relation. Given f of x, graph g of x equals to 2 times f at open square bracket 2 open round bracket x plus 1 close round bracket close square bracket subtract 3. So we're given the graph of f of x, and it's made up of a few different functions, and there's also an empty circle there. So step 1 is to identify important points that we use to transform this function. Step 2, we're going to rewrite the function notation as mapping notation because we're going to use the points from step 1 and transform them individually. And we'll need the mapping notation to do that. Step 3, we find the image points using the original points. And in step 4, we will graph the image points and connect the points together properly, and then we have to label the new function as g of x. So let's start from identifying important points that we need to use. So there are 8 points that I have identified. So you can see we want the start point, the end point, and whenever there is some change going on within the curves or the lines. So point A is -4 and 6. We have point B is an empty circle, which means it's excluded from the function, but when we're transforming, we want to include it so that it's easier to draw. So this point is -1 and 3. Point C is 0 and 4. Point D is 1 and 3. Point E is 2 and 2. Point F, we have 3 and 3. Point G is 4 and 6. And point H is 5 and 3. Step 2, we're going to rewrite the function notation as mapping notation. So we're given that g of x is 2 times f at open square bracket 2 open round bracket x plus 1 close round bracket close square bracket subtract 3. So this means that A, our vertical stretch is 2, K, our horizontal compression is 1/2, D is -1, which means there's a translation to the left. C is -3, so it means there's a translation down. So in mapping notation, it means that the x-coordinates will have to multiply by 1/2 for the compression horizontally, and then we will translate it to the left after. And then for the y-coordinates, we need to double it, okay, multiply it by 2 before moving it down by 3 units. So now we're going to use the mapping notation to find the image points. Point A, we started with -4 and 6. So we take the x-coordinate, which is -4. We multiply it by 1/2, which means we have -2. And then we -2 subtract 1 gives us -3. That's our x-coordinates of the image point. For the y-coordinate, we take 6, multiplied by 2, which means we have 12, subtracted by 3, so we have 9 as the y-coordinates of the image point. For point B, we start with -1, multiplied by 1/2, so we have -1/2, subtract 1, so we have -3/2. For the y-coordinates, we start with 3, multiplied by 2, we have 6. 6 subtract 3, we have 3. For point C, 0 times 1/2 is 0, and then subtract 1 gives us -1. 4 times 2 is 8. 8 subtract 3 is 5. Point D, 1 times 1/2 is 1/2. Subtract 1, we get -1/2. Y-coordinate is 3, So the result would be same as what happened with point B. So the y coordinate of D prime would also be 3. Point E, x coordinate is 2. 2 times a half is 1. 1 subtract 1 is 0. Y coordinate, 2 times 2 is 4. 4 subtract 3 is 1. And then we continue the same process for the rest of the points. Once we have generated all the image points that we need, we can graph our new function. So first, we graph the image points. So we have A prime all the way to H prime graphed on the grid. Then we're going to connect the image points correctly using lines and curves. So from point A to point B is a straight line. So from A prime to B prime is a straight line as well. From point B to point C all the way to point F is actually one smooth curve, okay, in kind of S shape. So we have to reproduce that from B prime all the way to F prime. And then from F, G to H, it looks like an upside down parabola. So for F prime, G prime, and H prime, we try to draw an upside down parabola as well. So here is a graph. So let's remove f of x so that you can see g of x clearly. Okay, just g of x. So this is what the curve, or sorry, not the curve, it's a curve and lines combined. So this function, g of x, looks like this. Okay, so remember to label it so that we everything is clear. So with everything put together, okay, with f of x back in, this is what the final product would look like if you started from f of x and you need to graph g of x on top of the same grid.